In previous session, we worked on the barbershop model where we learned the attributes. So we had the waiting area and then the barber. Customers entered, they went from the waiting area to the barber and then from the barber to exit. Right when they got to the barber, we generated a random number and then we look at the value of the random number, which we saved in a local variable. And then based on the value of the random number, we decided if the customer is a man or a woman or a child, and then we gave the customer corresponding tag. And then when the customer went to the barber, based on the value of the tag, we assign different processing time to the customer. Okay, so we did all of that and that's perfect. What I want to do now is to teach you guys a different method for assigning these tags that may be a little easier and requires less amount of coding, but I want you guys to know that because obviously this is a different method for assigning the tags, and I'm sure you guys are going to use that in your future models and projects and future jobs and so forth. So what I want you guys to do is to please open the barbershop model that we work on in previous session. And so open that model and then save this model as a new model in the same folder for week 6. But at the end of the name of the model, I want you guys to put alternative method. Now I want you guys to please, in the first line, in the waiting area, in the operation of the first line, when we generate the random number and assign the tag to the attribute, to the entities, I want you guys to delete everything except the part where we increase the working process, the general working process variable. Delete everything else. Okay. Just keep the working process because we use that variable to calculate the overall working process. So I'm fine to leave it there. That's not a big deal. But you can delete everything else that we have here in the first line in the operation section. Delete everything that we did for generating local variables and assigning the right tag to the entities. Now, I want you to come to the destination side of the first line. So that's where we said, okay, customers at the waiting area, and then the customer goes to the barber, okay? And right here, I can click on the rule and say that, okay, customers go to barber, and with probability of 0.3, 30% of them with a probability of 0.3, put the number, 30% of them are men. Okay, and then I'm going to use the logic window, the move logic window, to say that assign the right attribute to the customer. So I'm saving the tags in the customer type attribute, and if the customer is a man with the probability of 30%, I'm going to give it tag of 1. Okay, so that's all that happened in the first line. So customer went to the barber with the chance of 30% they are man, and right here in the move logic, I'm going to perform whatever I need to do to give the tag of 1 to those customers. Then I press enter. Next line, I still have customers that are going to barber, and this time with probability of 0.5, they are going to be women. And this time, I'm going to give the customer type, tag customer type 2. Okay, so that those 50% of customers are going to get tag of 2. And then next, again, I have customers that are going to go to barber, but these are the other 20%, 0.2, with probability of 0.2. They are going to get tag of 3, and that stands for children. Okay, so I assign the probabilities here right in the rule, and then here in the move logic, I assign the the tags, if the customers are going to get the tag of 1 or 2 or 3, representing if they are man, woman, or children. Okay. And then when the customer gets to the barber, as you can see in the operation window, the customer already has the tag. So all I need to do is just to look at the tag value and assign the right processing time and increase or decrease the right variables and so forth. Okay. So we assign the tags in the destination section. Also, if you remember, we calculated work in process for different type of customers. And in previous method, right here at waiting area, when the customers entered, and when I created that local random variable, and I assigned a tag to the right customer, to the customers based on if they are men, women, or children. Right here in the first line, I also started to increase the work in process. Okay, so now I want to ask you, if I still want to calculate the work in process for men, women, and children, where do you think I have to increase that variable?
And the movie logic?
Okay, okay, let's try that and see what we get. In the move logic, right in the first line, where I assign the tag of 1 to the customers, I'm going to also increase the men work in process. And in the second line, after I assign the tag of 2 to the customer, when I know they are women, I'm going to increase the woman work in process. And in line 3, after I assign the tag of 3, meaning that I know they are children, I'm going to increase the children work in process. Okay, so we do that. And then let's run. So we're going to run the simulation for 100 hours and let's see what we get. Let's go to variables. Okay, so you see in the variables, for the variable men, women, and children work in process, what is the column that I have to look at, the most meaningful column?
Average value.
It's the average value, okay? And if you remember, as you may remember from previous session, we also calculated one variable for work in process in general, okay? And you see now the working process for children, for men, women, and children is even less than 1, okay? And it shows that the maximum values are 1. But then on the other hand, for working process for the whole customers is 10, okay? So obviously these numbers do not make sense. Like how come there are 10 customers overall in the store at any point of time? However, when we look at the number of children or women or men, the values are less than 1. Okay, so these numbers obviously do not go together, so something is not correct here. Okay, so if I go back to the model, so what happens here is that the things that we write in the move logic are being executed when the move happens. Okay, when the customer is ready to go to the barber and the move is happening, then the things that we wrote in the move logic are being executed. The customer gets the tag of 1, and then we start to increasing the corresponding work in process. Okay, so however, if I'm calculating work in process, I want the work in process to be calculated right from the point that they enter the waiting area. As soon as the customer enters the waiting area, I want to see if they are men, women, or children. And then I'm going to increase the right variable, men work in process, women work in process, or child work in process. And I don't want to start increasing these variables when the customer gets to the barber, like what I wrote here. So here I said, okay, when the customer is moved to the barber and when the moving happens, then start executing these lines, which means you are done waiting in the waiting area and you're moving to the barber, then these lines are going to be executed and the right variable for work in process is going to be increased. However, I don't want that. I want, if I'm looking at work in process is for the whole system. And when I say the whole system, it includes the waiting area and the barber. So I have to be able to increase the work in process. As soon as the customer enters the waiting area, I want to increase the right work in process so that I can count them even if they are in the waiting area. Okay, so however, this is not what happens here. We are still good in the sense that we assign the right tag to the attributes. We still assign the right tag to the entities, and when the entities get to the barber, they have the right tag, and we are going to process them correctly. So we are good in that sense. But if you still want to calculate the work in process for men, women, and children, this is not the right way to do it. The move logic is too late to start increasing the work in process variable. Okay, so I want to be able to start increasing work in process as soon as they enter the waiting area. Okay, so this method is perfect for assigning the attributes, but this is not the right method or doesn't give us the right place to start increasing work in process. So if we are looking for calculating work in process, this is not the right place. So what I want you guys to do is to first remove the increase work in process part from these three move logic, the lines of code in the move logic, because I don't want you guys to get confused later when you look at this. So increase this. Okay, and yeah, so remove those lines. And also when you get to the next line, go to the next line in the operation. I want you also to remove the work in process lines, because obviously I'm not increasing it anywhere, so decreasing work in process doesn't mean anything either. So decrease the three lines related to work in process. So we just don't want to calculate work in process here. So let's just remove it, delete it from the first line where we increase them, and let's delete it from the second line where we decrease them, because with this method, there's no way for us to be able to calculate a correct value for the work in process. Okay, so let's do that, and then save this. Okay, save this. So let's keep this as one method in which you guys just learned how potentially you can assign these attributes to different type of customers based on their probabilities. And also I want you guys to pay attention that the sum of these probabilities should add up to 1, otherwise you get error. Okay, so when the customers come to the system, they are either men, women, or children with these probabilities, and the sum of these probabilities add up to 1, otherwise you get error. Okay. So I want you guys to save what we did here, and I want you guys to save this as a new model. And here we have alternative method, put version 2 at the end, version 2, yeah. So we are still looking at alternative method, but a different version, version 2. Save. And now I wanna, you guys, okay, let's try doing it a little different. So in the first line, customers come, they're at waiting area, and then they go to barber. And then on the destination side, I don't send them to barber right away. I said, okay, I'm going to keep them at waiting area. So the customer is at the waiting area right when they are at waiting area. As soon as they enter the waiting area, I'm going to look at them right at the waiting area, and with 30% chance, I'm going to give them tag of 1, meaning they are women. The rest of the customers, I'm going to do the same. I'm not going to send them to the barber right away. I'm going to keep them at waiting area. And right there, I'm going to give the probability of 50%, I'm going to give them a tag of 2. And for other group of customers also, I'm going to keep them at the waiting area, and with the chance of 20%, they are children, and I'm going to give them the tag of 3. Okay, so in this line, I'm still using the rules, the probabilities in the rules to decide if I'm going to give them a tag of 1 or 2 or 3. However, for the destination, I'm not going to send them anywhere. I'm going to keep them at waiting area, and that's perfectly fine. So the customers enter the waiting area, and while they are in the waiting area, I give them the right tag based on these probabilities. Then I need to specify a new line, because the customer is at waiting area. The customer hasn't gone to the barber yet. So I'm adding a new line here at the end where I said the customer, which is now still at waiting area with the tags. Now the customer has to go to the barber. And I already have a line in which I say, when the customer gets to the barber, look at the tag, process them based on these times, and then send the customer out. Okay. So in this method, I just kept the customer in the waiting area and assigned the right tag based on the probabilities. Okay. Now, in this scenario, if I wanna calculate work in process from the point that they enter the system till the point that they leave the system, is this possible here? We can just add it to the move logic. Right here in the first line, I say, give the right tag while you are still at the waiting area. You have entered the waiting area, and as soon as you enter the waiting area, based on these probabilities, I'm going to give you the right tag. And right here, since you are still in waiting area, I'm going to also increase the right work in process for each one of them. And also for children. Okay. So then right here, when they are still at the waiting area, with these probabilities, I gave them the right tag and I increased the right work in process variable, and I'm perfectly in good shape. I have started the counting of work in process variable when they entered the waiting area. And that's perfect because for the work in process to be a correct measure of the customers in the system, I have to start counting it as soon as customers enter the waiting area and decrease it when they enter. Then decrease it when they exit. For the decrease, I'm good because I decrease it when they get their haircut and leave, which we have to add here, by the way. So for the start, we're good. We just started to increase work in process when the customer is at the waiting area. And then now I have to decrease it as well. So let's go to the part when they get the service from the barber and they leave. And right here, we want to decrease the men work in process. And we want to decrease women work in process. And we want to decrease child work in process. Okay. This is what we had. We just removed it from the previous model because I didn't want you guys to get confused about not having the work in process variable and so forth. So we just removed it from the model completely. But that's why I just put it back here. So when a customer enters the system, we are going to keep it in the same area. And that's perfectly fine, guys. If you want to assign attributes or do anything based on some probabilities, it's okay to keep the customer in the same area and not necessarily send it to a destination. Keep the customer in the same area with these probabilities, assign the right tag, start increasing the right variable, and then take the customer from that point to wherever they go. And then in the barber, we assign the right processing time and decrease the work in process variable, and we are good to run the model again. And if I look at variable summary, you see now these numbers make sense. Now I have on average about 2 and about 3.5 and about 1 something of men, children, and women in the system.